I think the main takeaway is that these kinds of biologging devices, especially those capturing high-frequency accelerometry and maybe heart rate too, they offer a real path towards early warning systems for acute stress on the farm. Having that real-time remote monitoring capability, it allows for much more data-driven decisions, optimizing recovery times, maybe spotting sublethal stress that you wouldn't otherwise see, but that impacts performance.
A whole new era of communication in the global aquaculture industry is coming. Now you have the brightest minds in aquaculture right in your pocket. And what's best? You can listen to all of them while driving to a farm, traveling, or running errands. It's never been this good, and it's never been this simple. Welcome to the Aquaculture Podcast Show, the first AI-based podcast in aquaculture, where you'll find cutting-edge insights in everything that's working in aquaculture, nutrition, health, and production.
Welcome to this focused deep dive. We're jumping straight into a really compelling study today. It's about advanced fish welfare assessment, specifically for Atlantic salmon, in these more intensified aquaculture systems.
Yeah, it's a big topic. As systems get more efficient, we really need better tools for monitoring. Yeah. And this research tackles that head on. It looks at, the challenge of tracking stress non-invasively, continuously, in real time.
Exactly. And the angle here is biologging tech. They zeroed in on using heart rate and accelerometry loggers together.
Synchronously, yeah. High-res telemetry, basically, trying to understand the internal state of the fish.
Right. So our goal today is really to unpack how that biologger data, how it lines up with the standard physiological stress markers we know.
The idea is to give folks in aquaculture better tools, remote tools for checking welfare in real time.
Okay, let's get right into the study design then. What was the basic setup?
So they used 13 adult Atlantic salmon, and each fish was implanted with one of these combined loggers, heart rate and acceleration.
So they've got these instrumented fish. What kind of stressors did they put them through?
Well, the protocol started with a period of just controlled swimming, baseline activity. Then came the acute stressor simulation. It was a standardized netting and transport procedure. Pretty common stressor in aquaculture.
Right. So you get data on both normal activity and a defined stress event. What else were they measuring besides the biologger outputs?
Oh, it was pretty comprehensive. They had respirometry going for precise oxygen consumption, MOROs. They used video tracking too, combined with machine learning, to quantify activity in detail, like tail beat frequency.
Okay.
And of course, those repeated blood samples gave them the direct numbers: lactate, pH, plasma cortisol, the usual suspects for stress.
A lot of data streams converging there. So the big question, how well did that external biologger data actually reflect what was happening inside the fish physiologically?
Yeah, this is where it gets interesting. They found a pretty significant correlation between acceleration and tail beat frequency. The R-squared was 0.54.
Okay, so acceleration predicts over half the variation in tail beats.
And then that tail beat frequency, in turn, was a really strong predictor of oxygen consumption. It explained 73% of the MO variation.
Wow, 73%. That really connects the dots between movement and metabolic rate. But what about just the raw logger data predicting MO directly?
Yeah, good question. Accelerometry on its own, just the raw data, still explained a good chunk, 39% of the MO variation. But the real standout was the variance in acceleration.
Meaning how much the acceleration was changing rapidly.
Exactly, how jerky or smooth the movement was. That single metric accounted for, get this, 75% of the variability and oxygen consumption.
75%. That's huge, coming from a non-invasive sensor, just tracking movement patterns.
Yeah.
How did heart rate stack up against that?
Well, heart rate did show a positive correlation with MO. The R-squared was 0.34, so, it's a statistically significant link. But it was consistently less sensitive compared to the acceleration metrics, especially that variance metric.
So the way the fish moves, the variability in its movement seems packed with information about its internal state, more so than just heart rate in this case. The study really pushed this variance of acceleration as a key welfare indicator, didn't it? Beyond just activity level.
Well, absolutely. That variance metric turned out to be a significant predictor for several other key stress biomarkers too, not just metabolic rate. Let me see. It explained 37% of the variance in venous partial pressure of oxygen, PVOs, 16% in blood lactate, 5% in pH, 15% in MCHC, that's mean corpuscular hemoglobin concentration, and importantly, 19% of the variance in plasma cortisol concentration.
Okay, so those correlations really trace the physiological cascade during stress, don't they? Can you break down what that means?
Sure. It directly links the type of movement, those rapid, maybe unpredictable bursts or changes captured by high variance, things you might see in escape attempts or fatigue. It links that pattern directly to big shifts inside the fish. You see the switch to anaerobic metabolism with the lactate increase. You see the impact on blood acid-base balance reflected in the pH and MCHC changes. And the cortisol link ties it straight to the primary endocrine stress response kicking in. It's quite a clear picture.
Right. So after they did the netting and transport stress simulation, what happened immediately with these metrics? The acceleration ones and the physiological markers.
Okay, so right after the stressor, both the overall acceleration and that key variance in acceleration metric, they dropped sharply. Then they showed this gradual recovery phase. But interestingly, there were noticeable plateaus around 8.7 hours for acceleration and 8.1 hours for the variance. Took a while to fully stabilize.
Okay. And heart rate during that immediate post-stress phase.
Heart rate was actually relatively stable right after the stress. It didn't show that same dramatic drop and recovery pattern as acceleration variance.
Interesting. And the blood markers, lactate, cortisol.
Oh, they spiked, as you'd expect. Big surges. Lactate peaked at about 4.8 millimole a woman. Plasma cortisol shot up to 221.8 millimole mLO. Classic acute stress response.
Confirms the stressor definitely worked. How quickly did things normalize?
Well, most of the physiological parameters, like lactate and pH, were heading back towards baseline within about 24 hours. But cortisol levels stayed elevated for longer, which suggests, that neuroendocrine recovery takes more time. The hormonal signal lingers.
That extended cortisol response is definitely something to keep in mind for practical welfare assessment. And the study also mentioned something about surgical recovery times influencing baseline readings.
Yes, that was a really important practical point. They found evidence suggesting that short recovery times after surgery, like less than 48 hours, probably inflate your baseline readings for heart rate and cortisol. It really stresses the need for adequate recovery after any invasive procedure if you want accurate baseline data.
Makes perfect sense. So pulling it all together, what's the takeaway on the predictive power of these accelerometry loggers for salmon welfare?
I think the evidence is really strong. These acceleration-based loggers, especially when capturing high-frequency data, are powerful tools. They indicate not just activity, but also the underlying metabolic and endocrine stress responses. And again, that variance of acceleration seems particularly useful. It reflects that burst and glide swimming may be linked to stress or fatigue. Plus, its correlation with things like MCHC and blood pH shows it's relevant for picking up critical issues like acid-base balance problems or related blood cell responses.
And you mentioned it might even help predict metabolic debt after exertion. That sounds very applicable to routine farm operations.
Exactly. The potential to predict EPOC excess, post-exercise oxygen consumption, is really interesting. It suggests you could use these tools to gauge the actual physiological cost of things like netting or delousing treatments, grading, transport, and then maybe use that information to fine-tune those operations, minimize the stress impact, optimize recovery.
So for the aquaculture professionals listening, the practical message here is?
I think the main takeaway is that these kinds of biologging devices, especially those capturing high-frequency accelerometry and maybe heart rate too, they offer a real path towards early warning systems for acute stress on the farm. Having that real-time remote monitoring capability, it allows for much more data-driven decisions. Optimizing recovery times, maybe spotting sublethal stress that you wouldn't otherwise see, but that impacts performance.
It feels like a definite shift towards more proactive, precision-based welfare management.
It really does. It's non-lethal, provides continuous data. It fits perfectly with where precision aquaculture is heading. You get potential benefits for welfare and for production efficiency. Now, the researchers are careful to point out, and rightly so, that you need more validation work to extrapolate these controlled findings directly to, say, complex open pan environments. Hydrodynamics, social interactions. Those add layers of complexity you don't have in a lab tech.
Sure, context is always key, but summarizing the core advance from this study for the sector.
I'd say the key advance is demonstrating this really robust, mechanistically understandable link between the biologger data, especially that variance of acceleration, and the fundamental physiological stress indicators in salmon. It provides a solid scientific basis for using this tech in more proactive welfare monitoring in these high-intensity settings.
It certainly suggests accelerometry is giving us much more than just a simple activity count.
Exactly. That variance metric in particular is emerging as a powerful diagnostic tool. It gives you a window into the fish's metabolic and endocrine state when it's facing challenges, As this tech gets further validated and deployed, it really holds significant promise. Healthier fish, potentially better yields, more sustainable practices overall. It's exciting stuff for the salmon industry.
A very significant technical step forward. It makes you think, doesn't it? Consider how integrating this kind of continuous, real-time physiological data, how it could not only refine day-to-day operations, but maybe even help predict broader environmental issues or health challenges within the whole system. Definitely something to watch. Thanks for breaking that down.
If you enjoyed this episode, make sure to follow the Aquaculture Podcast Show on your favorite platform. And don't forget to follow us on LinkedIn, Instagram, and Facebook to stay updated on the latest episodes and industry insights. Thanks for tuning in, and we'll catch you next time.